Hello everyone. Uh, Firstly, I apologize for being uploading this tutorial a bit late, but here we are with the walkthrough of this ANSYS Workbench, and we are taking a very simple problem of stress in a rectangular plate with a hole. And in the end, we will also try to validate our FEM simulation with the analytical equations that have been established for such cases. So let's get into the case. As now, after watching the previous videos, you must be knowing that you can start the ANSYS programs by just clicking the Windows tab. And previously we were going to the ANSYS Mechanical APDL, but today we will be working on ANSYS Workbench. So you need to select this Workbench 2022 and whatever version you have. So you need to select the Workbench module. Once you open, it will look like something like this window. You will see some menu bars of different problems that could be solved using Workbench. But currently we don't go into this. This will just confuse you. So whenever you create a new project in Workbench, the first step is always to save that project in a separate folder so that whatever related files are generated to this project, they will be saved in a specific folder. Otherwise, if you just create it in temp folder or in some other uh, folder by default, then there will be a clutter and of information, and when you need this specific project, you will not be able to find it. So you just click here, the file, and you just click save, and you save this project. Now, today we are performing this static structural analysis of this plate with a hole. So for that, we will be using this static structural module. So you just need to select the static structural, keep the left mouse button pressed, and then drag that into the main working window. Once you did that successfully, you will see this menu bar of this specific static structural analysis. And here you can see that you will see different menus. Now it's a bit different as compared to the APDL. It's quite user friendly and its GUI is very good as compared to the ANSYS Mechanical. So it's a bit relatively easy as compared to ANSYS APDL. So first, uh, so here is I just zoomed and now you can see clearly every menu in this. So we have this in static structural, we have this engineering data. This is the tab where the material properties are defined. Then we will up, down, download or create a geometry, then model, then set up solution, and we'll go uh, step by step. Now, first we will I will try to teach you how you can manipulate the material model, or you can select different materials. It's sometimes a bit cumbersome for some newcomers. So you just need to right click on this engineering data, click this book icon, edit, and then you will see this menu will appear. So here I have mentioned different important things in it. Once you open this menu, by default, ANSYS always select the structural steel. But once you click this engineering data source, and you can just click this journal materials, and here after clicking this journal materials, you will see a list of different materials that are available, and even On your left hand side, you see there are a lot of materials depending on the type of analysis you want to perform. Since our case is just a static structural analysis, so we don't go into this hyperelastic or even some plastic materials. We'll just select the journal materials, and you can choose this if you want to, like, you don't want to, your material is not structural steel, it's aluminum. So just click this plus button, and this material will be then added to the material library. Once you are done with these three steps, you just go and close the engineering data from here. Okay, now the next option is this geometry. Now there are two options in which you can create a geometry, and there is another option in which if you have a previously created geometry, as in my case, I will be using here a previously created geometry of a rectangular plate with a hole. I will also upload this geometry so that you can just download it from this tutorial, and you can then follow this tutorial and do these steps yourself. Now in ANSYS, there are two modules of creating the geometry. One is the space claim and one is the design modeler. And the other option is the import geometry. So today we will be exploring how import geometry works, because I will make a separate video on the design modeler and on the space claim, because they are itself require another understanding video for this. So this is what, if you click the space claim, it will look like this. This is the design modeler. I'm just showing you the how does it looks, but you don't need to click on that. So we just go and click the import geometry, and then you just go to the folder where you have played your geometry. Now your geometry could be, you can see here, it could be in quite a lot formats. Like my geometry currently is here, is in the SAT format. Sometimes you don't see that geometry in the folder. So what you just need to easily do, just go to this tab and you just click all files, and then maybe you can see this SAT file, and different formats could be imported in ANSYS Workbench. Okay, now you see that just once you click that OK button, and then the geometry sign is, there is a tick in the geometry sign. So the geometry is imported. Now we just go to create the model. The model in Workbench is basically the mesh as we have generated in the ANSYS Mechanical APDL. If you have not gone through the tutorials, you can see the previous tutorials of using ANSYS Mechanical, so you know the terminology used by ANSYS. So a Workbench, it's a bit different. Here it called the FEM, the mesh, it's the Workbench called it's a model. So we just need to right click this model and click edit button, because it will create now mesh on the geometry which we have imported. Once you click the edit, you will see this, that the geometry created has been imported. Here I have deliberately created this geometry in different parts. You can also create your own geometry, a rectangular plate with known width and known length and known thickness and the dia of the hole. But I generated this so that you can, I will also upload this geometry so that you can see that the structured mesh, how it can be generated automatically if you just modify your geometry. Otherwise, if it's a single part, there's no partition, then ANSYS will create a triangular mesh for you. In a separate video, we will discuss on the difference between this triangular mesh and the quad mesh and the structured mesh, and how they affect the solution. So once you have imported the geometry, you just need to click this mesh. That's the first step. Then you just go to this sizing button, and here you see the resolution. You can refine your resolution like by clicking this arrow button, and just like I've taken here 6. When you're practicing, you can also test different resolutions, and you can also see the effect of coarse mesh and fine mesh for this simple model. Once that step has been done, you have selected the refinement level 6, then you just go to this mesh again, and you can see that the other parts are ticked, and here you see a lightning sign. This ANSYS space because now there's an update available for this mesh tab. So you just go and you just click generate mesh or either click update. It will do the same. So once you have clicked this generate mesh, you will see that a kind of this kind of mesh will be created, and you will see a tick mark besides the meshing tab. Next is the static structural type. I mean, which type of analysis we are performing. So for this rectangular plate, we will be holding the plate from the left side, and we will be pulling the plate on the other side. So you should go to this menu of static structural, insert, and then this fix support. I've also written the steps here. You can easily follow them. And once you selected the previous option, then you need to select this face, and this is the face which we will apply the boundary condition of fixed. And you just here, after selecting this, you see that the face will get green. Maybe you need a bit of hit and try to approach this surface. You need to rotate the model. So that's the easiest thing, but you can try. And then you just need to click apply. Once you see that the fixed support has been applied, so we are done with the boundary conditions. Next, we again go to this static structural. You see that still there is a question mark besides it because the loads have not been applied. So we just go to insert and then force, and insert a force load that distributes a force vector across one or more topologies. Once you click that, you just need to select again this surface, the opposite surface. Don't select the same surface. On that face, we have applied the fixed boundary condition. On this face, now we will apply the force. Just go to here and click apply. It will apply something, it will make red, but currently you'll see that no magnitude has been specified. So you just go to down here in this definition menu. We will define this force by vectors, and you can see that we have this direction in the positive x direction. So we will just select here components in the defined by, and once we have this, so we will apply this on the x component. We will type here with our keyboard 10,000, and this will be applied in newtons, the force, and the force has been applied. You can see it here. Previously the magnitude was 0, but now the magnitude is 10,000. So, and you will also see a arrow here. And here you don't need to worry about that how this force will be distributed. ANSYS Workbench is itself intelligent that it will distribute this 10,000 Newton force on this complete area. In Workbench, you need to select the nodes to do the same, and then you need to divide the force by the number of nodes and put that value. Otherwise, it will apply 10,000 force on each node. So in some tutorial we will also go through the APDL option, but here it's easy just to select this face and apply. Now you see that the question mark has been changed, since we have applied the load and we have applied the boundary condition. So we will now apply the, we just need to run it, but before running it, we need to see some solutions or post-process some results. So you can also do this later, but maybe before running the solution, you can also do that. That is optional. So just go to this static structural, insert deformation tool and total deformation so that we can see that how much is the deformation produced in this. And the next is you do also do the same. You go to solution, you go to stress this time, and you just select this equivalent one minus stress, and you just add this option too. Now there are different ways to solve. You can go to here solution, right click, update, it will solve, or there is a tab also. I'm just showing you this different options which ANSYS has offered. Whichever you like easily and you are comfortable with, you can select, you can do that. Just click the solve button. And after clicking the solve button, you can see the solution status downside, how much solution have been done. It shows in some percentage. And once the solution is done, it will say ready. And you can see now I have just clicked this static structural, and we are now seeing this equivalent 1 minus stress around 32 megapascal MPa. It's showing the unit system here. Now we will try to compare the FEM results with the with analytical solution that have been developed by here is the source of this Rooks formula for stresses and strain. That's a book in which a lot of analytical solutions have been defined for some simpler geometries like this one with plate with a hole. Here I've given all the formulations that have been taken from this source, and there are also parameters like the width of the plate, the dia of the hole, the force applied, and T is the thickness. So you can also use Excel sheet to put in these values, and you can also then play with these values by changing that. And you can see that when we click this, the sigma max we get is this is the sigma max. So we get the maximum stress of around 33.56. And from FEM, we saw that we get this so the solution of 32.66. So it's almost 2.6 percentage error. So that's not that much. So and you can see now you can correlate the theory with the numerical simulation. And in the end, if all goes well, in the menu which we've seen, you will see some that all the options have been tick marked. So your this module for the static structural is complete.